Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we unfold your brain with weird and wonderful science. I'm Ian Woolf. On this masked edition, retired rocket scientist Ian Bryce shares his observations about pandemic masks. What do you do when public health announcements leave out important information? Do mask valves release unfiltered breath? Ian Bryce is a retired university lecturer with a background in physics, engineering and rocket science. Ian has broadcast on Diffusion previously about weird gadgets he's investigated for the Australian skeptics. Please note that neither Ian nor I are medical experts. I spoke to Ian by Zoom. Ian, you've noticed something missing in the advice in dealing with COVID-19.
Yes, I have. I've noticed way back in April that there are quite a few problems in implementing the measures they're taking against COVID, particularly to do with masks. One thing that shocked me is that Woolworths in Balmain, I saw the staff diligently wiping down surfaces with disinfectant while breathing all over them.
Oh no.
I thought you don't have to be a rocket scientist, which I am, by the way, to see there's something wrong with that. So I did a detailed study and found out there are quite a few problems with masks, and since April I've been trying to alert people to those problems.
So they weren't wearing masks while they were wiping things down, is that right?
That's right, all over. In fact, they're still not. Since that time, Woolworths had an outbreak. The same Woolworths in Balmain had an outbreak of COVID. One of the staff was found to be infected. Well, I'd already told them months before that this was a danger when the staff weren't wearing masks. Since then, they're still there. I was there today, and they're still not wearing masks. They said they're going to implement from Monday new policies, which will probably recommend that their staff and customers wear masks. So that'll be a step in the right direction, at least. So that's one thing that alerted me. And the other was the many errors I see in the media by health authorities making statements about masks.
Well, there's a lot of things said, isn't there? And you seem to get different messages from the federal level and the state level and the health officers and the doctors, and I'm sure it can be very confusing.
Yes, but what alarms me is they don't seem to have any physicists among their advisors. They've got all sorts of mathematical models. I've spoken to quite a few of them to try and put together a coherent picture. When I described the physics of masks to them, they all said, oh no, I'm a mathematician, I'm a modeler, I'm an epidemiologist, I'm a biologist. I said, well, would you like to work with me to investigate some of these and bring it out? But I didn't get very far. I'm trying to do that now.
Oh, that's very difficult.
So I'm pleased to see, among other things, that masks have at last been put on the official agenda in Victoria, and they're probably on their way in New South Wales, so that'll be something.
Absolutely. It seems like it's just good sense, right? That we should do everything we can, and that masks look like they stop the little droplets as well as the big droplets, and we protect each other.
Yes, indeed. The N95 masks are, by definition, tested to block 95% of virus-sized particles. And if you're modelling them, you'd have to allow for some leakage paths, because everyone knows their glasses fog up, which means there's breath coming out beside the nose. So if you allow another 5% for leakage paths, then you've got about 90% efficiency. So this is an example of a N95 mask. So they're shaped and they're designed to fit your face fairly well. And this is an example of a surgical mask, which has got another set of problems, which they also seem to be unaware of. So I've been trying to draw people's attention to two of these problems, which can be easily overcome.
So I know a lot of people try to overcome the steam problem, where their glasses fogging up, by having a valve. But that's not really filtering what comes out, is it?
That's right. When I've asked people what it is, many of them have told me that it's our special filter. Yeah, that's right. What it consists of is a little rubber flap. In this one, I've cut away the grill that covers the front. So you can see there's a little rubber flap there. And when I exhale, the flap lifts up and my breath comes out unfiltered. So if I'm mopping the surfaces in Woolworths or on the bus, my undiluted breath is filling the air and depositing itself onto surfaces. This hasn't been picked up by anyone, as far as I know, since I've tried to draw the attention of authorities around the world to it back in April. So that's the exhalation valve, and it's quite obvious. In this particular case, you can see that I've cut away the cover so you can see it, and I've also glued up the inside. So there's a silicone. So this is a non-functional exhalation valve. So that one's COVID safe. So I believe that the ones with an exhalation valve, their sales should be restricted in some way. Those should be labelled not COVID safe or something like that.
That sounds like the right way to go. It's very hard to ban them, but to label them as not COVID safe seems the right way to go, because as you say, if it's just a flap, then the droplets just get out and you're contaminating everyone around you if you've got an illness and you're not showing symptoms.
That's right, and it brings out another myth. I've had some people wearing this type of mask who've come up to me and said condescendingly, "You realise this is for your benefit, not mine." And I say, "Well, hardly, since your unfiltered breath is going all over me. Thank you very much." So the other thing is, you might have noticed Four Corners had a program on the Italian disaster about a week ago. The lady doctor who starred in that showed the workings in the hospital, and half the valves that the medical staff were wearing had an exhalation valve.
Oh no.
And none of them knew. So you don't have to look very far to find one of the causes of spreading, both in the community and in hospitals. So again, this needs to be brought urgently to the public's attention, I believe, that if there's an exhalation valve there, it's not protecting anyone else from COVID.
And
in fact, the chief Tedros Ghebreyesus from the WHO, head of WHO, was on TV last night showing a variety of masks which he said were beneficial, and one of them had an exhalation valve, so he doesn't know either.
Oh dear. So I guess if you're wearing a mask with an exhalation valve, less droplets will reach your nose and mouth, but any number of them could escape out to other people.
That's right. So there's no protection against those around you or against surfaces.
So it's a selfish mask.
It protects you very well. The purpose of these masks originally was to protect people doing industrial processes like grinding from dust particles and fumes and so forth. They were never intended to protect others from the breath of the wearer.
No, I mean,
that's my message.
Right.
Well, let me point out another observation. I warned about these back in April as well. I'll just hold one up here.
Is that a disposable one? With the blue on one side and the white on the other?
Yes, they typically come flat packed, and you'll notice they've got a blue side and a white side. And if you walk down the street, there's quite a few people, more in Melbourne than Sydney at the moment, wearing these masks. But there's one little problem. Half the people have got the blue side out and half have got the white side out.
Oh dear, and they're very different.
So it's quite likely when they go home, they take their mask off, put it on the table. If the mask goes flat, they put it on, go out again, and they've probably reversed it. So all the virus which was on the outside from the community is now turned towards their inhalation. So that's definitely a bad situation.
So for the listeners, which colour should be outside and which should be inside?
Now, which way round should it be? I don't know. It doesn't, in my opinion, it doesn't matter as long as we all do the same. In fact, it'd be okay if you always did the same.
Well, I saw something, I think, from Dr. Norman Swan. He was saying that there is actually a difference between the sides, that the blue side is more water repellent and the white side is more water absorbent. So the blue side should be outside to repel the droplets coming toward you, and the white side should be inside to absorb the droplets coming from you. So the blue should always be outside, And if you see anyone wearing the white, it's not working properly. And it's probably going to hurt them more than it hurts you.
Okay, well, there's something I didn't know. So the blue should be on the outside. Well, there you go. So,
Yes.
so I've written to all the manufacturers that I can find in Australia now and the importers and suggested that they put a simple label on inside and outside, which will overcome the problem.
Yes.
I also told Norman Swan that, and he did have the courtesy to reply and say he was looking at it.
Oh, that's
So
good. I think it matters because there's nothing to tell you. And until I saw Norman Swan, I was doing it randomly because I had no idea.
Yes, so that would be a very simple, zero-cost solution, at least for the masks made in Australia. And the ones we're importing, it's a simple matter to tell the supplier that you want them labelled with an inside and outside, because once they realise that problem, they'd probably be very happy to take it up. In fact, it could be a positive sales item as well.
I think it would be.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
You would expect that there should be basic public health announcements about how to wear masks. We seem to be very slow to get them in public health announcements from our government in this pandemic.
Yes, I'd be very happy to give them some tips on these things that would look at some of the aspects of physics.
Absolutely. And then, of course, there's the issue that the advice is that you can't reuse a disposable mask because any way you try to if you reuse it, as you said, it could still be contaminated. And if it gets wet, I believe it stops working. It doesn't filter properly.
Well, nevertheless, I think it's still a lot better than nothing. So compared to the current situation in most of Australia, where the majority of people don't wear masks at all, any sort of mask, particularly a professionally made one, will be a lot better than nothing. But all we need to do is alert people to these little issues to make it effective.
I think so. I think once we've got people wearing either disposable masks correctly or reusable masks without a valve, and of course there's the cloth masks that have a filter and the cloth masks that don't have a filter. There's all these disposable masks being thrown out all over the place. It's a pity there's no way to recycle them. Someone needs to come up with a brilliant idea for other uses.
That's right, but maybe they don't have to dispose of them every use. Physics comes to the rescue again, and if you read all the literature on the subject, which I did back in April, the longest lifetime of the virus on any surface within certain constraints was 7 hours half-life. That means that if you leave the mask sit on the table, 50% of the virus anywhere on it will decay away. And if you leave it there overnight and wear it again for a similar time next day, that's 21 hours, that's 3 half-lives, you'll be down to 12%, which is getting down to the background levels without a mask. So I believe under those figures, it's quite feasible to reuse a mask once a day, and if you go out several times a day, then you should perhaps several masks and cycle through them one at a time.
To allow more time for the virus to die.
That's right. So that you don't, if you wear one in the morning, you don't wear it again in the afternoon. You leave it till the next day's morning, by which time it'll be down to background level, say 10% of when you last took it off, which is about the same as the protection you could expect from it anyway. So yes, in my opinion, the physics shows that masks can be safely reused as long as it's only once per day. I wore a shaped mask like this as an experiment every day for a month. And after that month, it started to smell. It obviously had collected some material, so I threw it away. But there was apparently no degradation, not likely to be any significant degradation of its performance for a month's wearing. So I thought that was a good sign that suggestion that masks can be safely reused. And I've been trying to encourage some other researchers with laboratories, better laboratories than I, to actually do some tests on these things. But I think it's quite interesting that you can draw all sorts of conclusions just from a few simple tests and observations and some theoretical physics.
What do you think about some of the ideas going around that you could sterilize a mask to reuse it by either putting it in hot water or putting it in a low heat in an oven? Are two of the different ideas I've seen on YouTube, for example. But it seems to be against the general advice.
Well, I did tests on that, as a matter of fact. Not whether it kills the virus, because that had already been done. So yes, 70 degrees C for half an hour in the oven, and I found out the mask was not degraded at all, any of these masks. So they could be, and it's known that 70 degrees C for a few minutes even will kill the virus. There's no doubt about that. So that's been done by other people. So therefore, you can certainly sterilize them. But there's practical problems that need to be looked at. My old gas oven doesn't have calibration at those temperatures. The thermostat doesn't work below about 200 degrees C. That would be enough to melt the elastic and damage the mask. So that's not practical. However, some more modern ovens with electronic thermostats do have settings as low as 70 C. So I believe that they might be one alternative. In any case, if the heat damages the mask, it'll be plainly obvious when you pull it out there that it's no longer serviceable. So that's again something that could be considered. So A, yes, you can sterilize them, and B, you probably don't have to get sufficient protection from them.
Have you looked into the cloth masks at all?
Oh yes, there are several groups. I think it was Stanford and a research body in Hong Kong did tests on homemade masks back in March and April, and their results showed that if you took a random selection of cloths, their filtering efficiency went down from about 95% for the N95s down to as low as about 50% in stopping the virus. And they're not as effective as the professionally made ones out of proper materials. On the other hand, you can buy the N95 filtration material online and make your own masks out of that. So that would be another possibility.
Well, I know some of the cloth masks have space for replaceable filters. So you wash the mask in hot water and you replace the filter when it's dry. So you can just have a different filter every day but have the same mask.
Okay, great. That would be certainly a good option.
Oh, there you go. So that's sort of midway between the other options in a way.
Yes, so there's quite a few options there. There are some other things that you can model using physics, and a simple one is that how effective are masks in how far the virus goes? Well, if we have a 1.5 meter rule, it's a simple matter that applies without a mask, and you can then work out that if your mask is 90% efficient, given various parameters, you can then work out that you could, instead of having one person at 1.5 meters, you could have 10 people at 1.5 meters for the same protection, because the mathematics is quite straightforward as regards the spread of the virus. You don't need to know the details of the virus. It's because the mask or the distance or the number of people or the winds, they all affect the virus in the same way, whether or not you don't need to know how many you need inside you to infect you. The physics alone tells you all these things. And one thing that it shows is that instead of having seats on buses and trains well separated, if everyone there wore a mask, or at least even if 90% of them wore a mask, remember that's filtering their exhalation. Nearly all of the virus comes from the airways, the nose and the mouth. So if nearly everyone wears a mask, it means the contamination on surfaces will go down about 90%, and the contamination in the air will go down about 90%. So you could have every seat occupied, in which case people's heads are about 400 millimeters apart, 0.4 meters, compared to the current arrangement where they're about 0.8 meters on buses. And you could fill up the public transport again and be in a much better situation than you were under the current situation without masks. So again, physics to the rescue. So it's very easy to compare one set of precautions with another, and shows that picture theatres and, I was going to say restaurants, but it's not so good to eat and drink with a mask on, very difficult. But in cases where you can wear a mask, if you did wear a mask, it would give a great improvement in safety in all of these public place situations.
It's amazing. You would have thought that since the government's so keen to have all the businesses open up again and things almost business as usual, that they'd be really pushing for everyone to wear masks every time they're outside so that they can relax business rules.
That's right. I think if they were to adopt some of these guidelines and some more analysis, they'd find that you could basically restart a large portion of the economy while having an improvement in the community transmission aspect. Another example of where mathematics can be applied, how far does the droplets from your breath go? Well, that depends on many things, but a simple analysis of physics that says that the viral count that comes out of your mouth, on average, if you're in a random situation surrounded by other people uniformly in all directions, it will spread out on the surface of a sphere on average. And that means you can work out the risk to another person given their distance away from you and how many people there are and the wind speed according to simple inverse square law, it turns out to be. So again, you can do very simple comparisons of the different precautions. And that way you can work out whether you should allow people on the beach, because you can easily work out the dilution of the virus due to distance. In fact, when you do pollution control, as I've done in some other studies, there are several parameters that you learn that can be applied to pollution, and one is the lifetime of the pollutant. We know the lifetime of the virus, it always appears to be 7 hours or less, half-life, and usually a lot shorter. And the other one is dilution, and that follows the inverse square law statistically under certain conditions, as I said, for someone breathing out. So you've got the lifetime of the pollutant and you've got dilution. And the other one is transfer. Like they say, if you touch a mask, there's a certain probability you'll get virus from your mask to your face and your face to your hands and your hands to the kitchen table and there to a partner and so on. Well, simple tests show that under all of those conditions, the percentage of any material which is transferred by touching is a very tiny fraction of what was there to start with, like 1% on some of my tests. And that means that the transmission by touching, with a few simple precautions, has to be far, far lower than the other paths. So again, physics can be applied to indicate what would make sound guidelines and what wouldn't.
The power of physics.
Indeed. I know you're a fan of physics, Ian. So
I am. So basically, you're telling people, be careful that you're wearing a mask the right way around and that you're consistent with the way you do it so that you don't hurt yourself, that you can reuse it if you can't afford to have a new mask every single day, which is expensive and difficult for a lot of people, especially with unemployment rising astronomically. And don't wear a mask with a valve, and if you do, clog it up. Block it.
Yes, so they're the main messages I'd like to get out there. So I've been pushing these since April, and some of them are slowly filtering through, it seems, into the announcement by authorities. But I'd like to see that happen a lot faster.
I think a bit of physics and common sense go a long way.
Indeed.
Well, thank you, Ian, very much.
And thank you, other Ian.
That was Ian Bryce on applying physics to face masks. The current medical advice is still to only use disposable masks once, and then dispose of them. I'm keeping my used masks in a bag, in hopes of inspiration of how to recycle them, rather than have them end up in a dump. I plan to use a cloth mask with a salt-encrusted paper towel filter in the pocket, as explained in 2 previous episodes, with a second cloth mask for when I'm waiting for the first one to dry from being washed after a day's use. The video of this Zoom interview will go onto YouTube in time. And that's all from us this week on Diffusion. A big thank you to Beth for donating through PayPal, and to my 4 monthly donors on Patreon, Stormy, Yevgeny, Joanna and Ian. Joanna and Ian. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2 RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, 3 NBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.